welcome back to the Integrate Intelligently podcast. I'm your host, Jeff Brickler, accompanied by my brother, founder and CEO of CAD Talk Software, Scott Brickler. Today we have an interesting episode, very topical, the supply chain resilience through better data and how the accurate bills of material impact material planning and manufacturing. So Scott, good to be with you today. This is an interesting topic, that's come up again in recent times, mostly because of some new policies, some federal policies that are coming out of the U.S. government. So it's a good time to talk about those policies and how they affect manufacturing.
Absolutely. I think the last time supply chain got this much coverage was during COVID, with all the disruptions we had during that time. So,
right.
I think it's going to be interesting to talk about like how we help with that, but also, how, I think people would be astounded by like how complex, like everything they buy and own, how it all comes together to end up in their Amazon box.
Right. So that's a good jumping off point. So obviously yes, I've been working with manufacturing companies for the last decade here, but like you, 2 decades at least, maybe longer, maybe 3 decades. We don't want to get too far down that road, but maybe talk a little bit. What does it mean, a supply chain, and maybe give us examples of what that looks like, or just so we can set the basics for like what a supply chain is, and because it's not a term we hear all the time.
Yeah, I mean, I was actually thinking about this before the call. I think. Actually, probably the most relevant example that has the most, day-to-day would be like your car that you drive, right? So you drive your car, you buy a car from Ford or Tesla or wherever you get your car, but that like they didn't make everything that goes into that car. They don't, right? They buy the car. So the first link in the supply chain is the car manufacturer. Actually, it's not even that. It's probably the dealer who bought it from the car manufacturer. So there's 2 links in the chain right there, right? And then that car manufacturer is a lot of times they just have assembly. So then they're buying like depending on the car, they're buying the carburetor and the engine and all these pieces are coming together. And then that's the second link. So they're buying those sometimes from vendors and they're assembling them. So that's another link in the supply chain. So and then all of those people are subsequently buying the steel and the castings and all these different, the electronic components, all of these things are all the way chained all together with all these dependencies to come together to give you a car that you can buy at the dealership. And any disruption in any of those parts keeps the car from being shipped, right? So there's actually here in Cincinnati, we actually had, there was a speedway down actually in Kentucky, which is where I live, like not too far from here, where they actually had during COVID, the entire motor speedway, it's like a racetrack, was full of trucks from Toyota, I believe, missing one chip because they could not get from Asia this one chip to make the entire car run. And you plug the chip in and they drove off with it. Without the chip, it can't drive. So one chip. So that just gives you an idea of like the complexity of all these different companies all over the planet coming together to make a truck. And without that one thing, it doesn't drive.
Right. Yeah. No go. No good. Yeah, can't do anything with it. Yeah. So that's something that I don't think I appreciated until I started talking to manufacturing companies and working at CAD Talk was like complex. Like, of course, you'll hear in the news, and I didn't understand this for many years. You'll hear in the news about globalization, and maybe we heard in COVID the sort of the breaking down of globalizations, this global supply chains, and what that means is, I think, is that manufacturing companies, wherever they are, whether they're in the U.S. or elsewhere, to your point, they get their materials, whether that's a purchase part or raw material or just whatever they need to manufacture, they get that from somewhere else in the world, right? They could get that from 6, 7, 8, 10 different countries, even, all to come to one location to put it all together in the end.
They absolutely do. I mean, you think about, the world is so much more, there's a lot more complexity than people realize. It's like, you think back in the ancient times where you had a blacksmith, literally forging the thing out of ore that he poured out of the ground. There's not too many links in the supply chain there, right? So there's less disrupt, but like as we create more and more complex products, more and more diversity and all these things that we supply, no one can very rarely are people what they would call vertically integrated, which means they own the entire supply chain. And you think in a lot of ways, it's actually good that they don't, because it creates less risk. There's multiple players, multiple people competing for that same work. And it also creates its economy, because all of those, there's actually a little bit of money being made and margin being made at all of those exchanges, which then feeds the entire economy. So you're not to get into macroeconomics, but this is basically how economies work, is all of those little chains like that. So, that allows us to have very complex products where people can focus like on this little widget that goes into this piece of the car and make that their only thing and really optimize that. And the combination of all of these people focused on optimizing all these little pieces make for the amazing technology that we have today.
Yeah, it also allows in a global supply chains, which is what we've been having really the buildup since World War II. After the end of World War II, we've really built out those global supply chains, right? Elsewhere in Asia and Mexico, here in the U.S. and even Canada and just all these different places. We manufacturing companies, regardless of where you are, pull from different countries, and we created that global supply chain to allow other countries who specialize or have the right raw material to make those things, or special technology or cheaper labor, or a whole sort of a myriad of reasons why those countries or those areas, work on just that small amount, right? So maybe just making the steel, or just making the chips, or just, as you said, making one small component that's still critical. And then as a result, all those different countries, all those different manufacturers across the globe come together into one product, right? Like your car or any other sort of complex product. The more complex the product, more likely the supply chains. I think about like chip manufacturing, like silicon chip manufacturing, and how complex that is. Getting tooling from the Dutch, right? Getting silicon from another place, and manufactured in Taiwan or Asia, or even the U.S. Just all these different complexities, all these things have to come together just to make this a really complex product.
Absolutely. It's you could debate whether or not that's good or bad, or why it's that way and that kind of thing. I mean, there's lots of pros and cons of a lot of these things, and we're not trying to get political on this debate. It's just more kind of educating and understanding why it is that way and kind of how it evolved that way. And then and just kind of what is our small part in this, as far as an integration software between that works between engineering and manufacturing software. And I think it's definitely a piece of that. I mean, we could tie that back to us by saying that everything starts with, especially if it's manufactured, everything starts with an engineering design, everything, right? So we call it art to part, right? From the art of the brain of the person who created it all the way to the part that gets made, right?
Never heard art to part. That's a new one. I never heard that.
Oh, okay. I thought I used that term before, but
I never heard that. It's good. Good.
When I was engineer, that's what we call it, art to part, right? So, so you're coming from the engineer's mind and bringing that into reality, right? And so that everything's now it's interesting, with the supply chain, they're usually conceiving of things in the context of things that exist, right? They're going to use standard bearings, and they're going to use standard other things and steel and things like that. But sometimes they don't. They conceive of new materials, and they conceive of new things, right? Those are all. But push comes to shove, everything comes from an engineering design that's manufactured of some sort, right? Some kind of engineering design. And our job is to streamline the transfer of the engineering design into the supply chain systems, which is usually ERP or some kind of downstream system. So that, and there's lots of benefits to that, and we talked about in other podcasts, but. We can, first of all, would be, the work it takes to do that, which is what everybody sees. That's the hard cost of savings of doing that. But let's talk a little bit today more about the soft cost of and that's the reason we started with the supply chain issues. If the faster we can do that and the more accurate we can do that, the more resilient you actually are to the supply chain issues, because you're able to react and change that design to deal with whatever the supply issues are, those types of things during the process. So our job is kind of, it's very important to make sure that we are bringing that data over, and we're bringing it over accurately, and we're bringing it over quickly.
Let's kind of I was thinking through this. Let's kind of step through the scenario. Let's say you're an engineer, right? You're designing this product. You release that product, and it ends up in the ERP. And what's the likely result, kind of, if there is supply chain issues? And my imagine is once it's in the ERP, you get people got to have purchase orders to buy the products, to buy the things. Well, what happens what happens next? How does supply chain interruptions, changes, tariffs, or whatever challenges, whether that's COVID or tariffs or anything that messes up the supply chain, how does that kind of ripple down into like just the individual's work? So the engineer did his part, right? Designed his or her thing, that did their thing. That's over in the supply chain system, which is the ERP. Now what? How does those challenges out here, right, in the global, how do they affect a person who needs to then source that stuff?
Well, first of all, if the data is not brought over, if it's brought over manually or has mistakes, then you're going to be buying the wrong things or not the right amount, right? That would be the first thing. So you want to, that's like table stakes, get the data right, which obviously we would help solve. The other thing would be that, like, if I'm an engineer and I'm like reacting to that situation, say let's go with the example of the car, right? It'd be very difficult with the car, but you like, okay, well, we can source we can't get the chips because of this supply chain issue. Can we get different chips, right? You'd ask that question. You're like, we can't ship cars. We can't make profit. We can't do what we need to do as a manufacturing company. What can you do? Can we build something? Can we build a chip that would plug in there to make these cars go so we can sell them? And you're like, well, yeah. So you start investigating that as the engineer. He goes, well, the chip works like this. And actually, if we buy this other chip that we can get from another country or or here in the United States or whatever, we can retrofit it to then deal with this by adding this other component or something, whatever. Just say that's an example of way you could do that, right? Then you're like, you're able to figure that out and convey it into the system and make that change quickly. You can react to a short-term issue, right? Because you're going from art to part to supply chain very, very fast, right? So you're saying, how could I do that transfer? As opposed to like every step in the chain, to communicate the information becomes a bottleneck to be able to have that kind of reaction speed. So that's the idea, is like, it really comes back down to the engineer deciding, okay, I can't use X. Now I got to use Y. And what do I need to do to make Y work? And that's how you can make yourself a little bit more resilient to those types of issues. I mean, when you design things, you're always, this is true of code or engineering work, or if you're designing machinery, everything's a game of trade-offs, right? It's all a game of trade-offs. Like, it's optimizations, right? So like in code world, I can make it fast, but typically when I make it fast, the code isn't easy to read and understand. Like I can make it flexible, but then it becomes more complicated. Like, there's all these trade-offs. In design, you do the same thing. It's like, well, I can build it out of the cheapest material, but it might not be as strong. Or I can build it out of expensive material, but it might not be as common. It's like, what am I optimizing for? Am I optimizing for more common materials to optimize for the supply chain, or am I optimized for the engineering problem? So if you change the constraints, like the supply chain is now the major constraint, or theory of constraints, the main bottleneck in the system is now the supply chain, I can design it differently, optimizing for the supply chain than I could have before. Does that make sense?
Yeah. So it also gives how important, like, lead times, like how important the data is, right? So lead times for alternate parts, or lead times for not just alternate parts, but also like alternate parts or alternatives, or the need to say, yeah, we can use this alternative part, or how important it is to get that information back to the engineer to make a decision about, like, well, okay, we can't manufacture this anymore based upon what our original design. Now let's go back to engineering. They have to redesign it within mind to say, okay, we can't get part A, but we can get part B. We can get part B from this other source, right? Other country, or cheaper, or whatever. But that was going to require, a redesign. And the engineer has to then get that data back as quickly as possible, or know that ahead of time, right? Know ahead of time that from the ERP data that, hey, this part, we can't get these parts, or any parts that are sourced in this country, we can't get them anymore, or they're highly expensive. We got to get them from somewhere else. And the faster the engineering knows that information and can adapt, to your point, they can make those changes that take in the trade-off of the supply chain, right? Whatever's happened to the supply chain. So getting that data back quickly to the engineer, who can make the changes, so then it can then can push those changes back into the supply chain. Because what happens as soon as the supply chain is disrupted, then everybody goes to this like news source. Well, this news source of that part. Well, think about it. If you have about five companies getting it from all over, and now, this whole country's closed off, and you're, 3 of the 5 vendors that you can source it from in this one country. Now everybody's going to go to the 2 vendors, right? The 2 other vendors. The speed at which you can like get your stuff retrofitted and your parts ordered, the more likely you are to get them, because what's going to happen is like those 2 vendors are going to sell out, or they can't keep up because now their demand just went double or triple.
Yeah. I mean, I think about this, like, it's really interesting is that like in the reason, like, having been in both software world as well as the manufacturing world, that like the software world like borrows a lot of things from the manufacturing world. It's really interesting, like processes and the way they do things and things like that. But there's actually a case where you can make the reverse. Like you can take something from the software world and apply it to the manufacturing world. And one of the things they have in the software world is called continuous integration or continuous deployment. So what you do is like, if I find a bug in the system, one of the things that people work to is like, I want to be able to fix a bug, check it, and then have it immediately deploy to production through a bunch of gates, but it's all automated. And the reason that is because at every step along the process, if it's manual, you could reintroduce a problem in a very complex system, right? So what we do is we have it ourselves. Like we have automated builds and things that go out, and there's all these tests that run and all this stuff when we build Cat Talk. So if I make a code change, like that speed, like once we verify that it's working, everything's good, the speed that it can go through the steps to get deployed to a customer is very fast because of that, right? So that our reaction can be very quick to fix a bug or some kind of issue or to deploy a feature or something like that. Well, if you apply the same principle to manufacturing, it's like we have a bug in the system. There's the supply chain issue. I need to redirect. I need to change. So therefore, it goes back to the engineer. We decide on an alternate plan. We make the change. We implement the change in the design, and now we need to move through those steps to deploy as fast as possible. That's where CAD Talk comes in.
Yeah, because otherwise, if you don't have a modern ERP system or you have using spreadsheets, or you don't have any kind of integration and everything's manual, to your point, right? Like not only is it slower and you can't react as fast, but also because of the supply chain disruption here ripples all the way through the organization. Every gate, as you put it, right, is now even slower than before because now, right, you got to look at the spreadsheets, got to look over here, you got to revalidate the data. It's all this very manual grinding through, finding, checking to get through those gates. You can't use any automation, any time, quicker time, shorten the time scale because it's all manual. And so that really going to slow down the system, right? If you don't have the data that you need, the quality of data is not there, or the systems you're using is all manual, right? I just imagine that you talked about we having automated gates that we go through. I mean, imagine if a manufacturing company didn't have those automated gates, right? It's like somebody's got to make that decision all along the way.
Well, and they're also in a rush. And
right.
Like, what happens when people get in a rush? I mean, it's like they make mistakes. I mean, it's just what it is, right? So, I mean, that's the beauty of software is it just does the same thing every time. And it doesn't care. It doesn't get in a rush. It goes fast regardless. Right. So humans, like under stress, make mistakes. They do things like, oh no, we can't get chips. And then it's just like, what do we need? Rush, get everything through, get everything through. And then it's like with that, if it was just like, okay, make this change and everything else is automated down the line, then it doesn't matter. It's fast. And that's why in the software world, they've gone to this automation. It's almost like it's table stakes now for doing good software development. We don't make manual builds and deploy things. We don't do any of that stuff. It's all automated because that reduces the friction to deploy and get things out into the world because the complexity is so high and it's too easy to mess it up.
Right.
Yeah.
No, that's a good point. Because not only are things kind of the outside world is having effect on you, now you got to go through all those other gates, all those other processes again, right? With those changes that you weren't expecting, and then they're all manual, and there's no automation, there's no integration, there's none of that. It's like it's hard to make those changes, and it just slows you down, which then means that you can't get to your product to the customer faster. You may not even get the parts you're able to your point, like Toyota just setting those things out there because they could not get what they needed. And then you just have all this capital built up in the product, but you can't sell it.
Mm-hmm. Yeah. It's the golden gear issue, right?
Right.
The gold, the old manufacturing thing is I have everything I need, but this golden gear that would make my thing work. And then you can't collect money. You have all your money tied up in capital, an inventory that's sitting, not able to be used. And the golden gear, the golden sprocket, not the golden gear. The golden sprocket is always the thing. But yeah, it's a bad problem.
Yeah, it's just amazing how much like those from a whether that's going to be I was going to say a political standpoint or like changes in the politics or changes in supply chains caused by those things, or even by like what happened with COVID. All those changes have a huge effect in terms of planning and accuracy. And so it talks about how important to have the basics covered, right? I think there's always this kind of saying is like, if you're struggling with I think it's in anything in life, you're struggling with the basics, right? Or you're struggling with the sort of fundamentals, then any disruption really has a catastrophic effect on the whole system.
Yep, absolutely.
So Scott, what are some other examples of how the systems work together, or how a bill of material accuracy can help sort of future-proof or make more resilient engineering and manufacturing companies against these disruptions?
Depending on the systems that you own and things like that, obviously, just to mention like the accuracy of the bill and making sure that we're driving them through is, the accuracy of the bill and making sure that the right quantities, things like that are in there is paramount. But there's other features that some ERPs have or some systems have for like alternate parts or alternate materials and alternate routings and things like that. Though, if you maintain those, you're actually building in a certain amount of resilience to that, right? If you're like,
right,
I have a routing steps based on, a lot of times people route parts, if they have a manufacturing facility based off of the machinery they have, right? And which makes sense because they have that machinery. But like, if it has to be outsourced or they have a different plant or you haven't, like the machine goes down or you need to do an alternate routing, all of those things, once again, that's a supply chain of disruption. It just happens to be a supply chain internally, right? So if you could plan around those, you could plan around that, then you have those, then you know what to do. You can switch gears and say, now that the laser's down, but we can still do it on a router, or we can do it with a torch or something. You have a plan for how that would work. The problem would be if you're a manufacturing engineer and you're evaluating every design that comes through, you probably don't have the bandwidth to constantly create these alternate paths, right? It's like you're mitigating, so it's a risk reward scenario. Like the time it takes to do that compared to the benefit that you're going to get, how often is that going to happen, right? So you basically re-evaluating everything for an alternate path.
Right.
Well, with, we think of ourselves as being an AI driven application because we are. Like with AI, that problem becomes less of an issue, right? You can start planning multiple paths to achievement and doing really cool things like that, where you're saying, okay, not only do I have the thing that the engineer designed, but I also can infer or start figuring out alternate paths in case of certain scenarios, and building all those out ahead of time. So so the software, everything can just immediately choose, like, can't do this, now I can do this. Laser's down, go to the router. Because otherwise that's another point that this person has to decide, well, how do our laser's down, what do I do? Well, the software can just, if it has alternates, it can just do it.
Right. So if I understand you correctly, if your ERP system has the ability to handle alternate parts, alternate routings, alternate scenarios, and you build those out, that can help you be more resilient to supply chain issues, to any really issues, not just supply chain, right? Could be for your machines, but it also could be for parts and where you get those parts, how you source them, alternate bills of material, alternate routes, alternate vendors, where you can get those from different countries. If you build out all of that data, then you'll be able to respond more quickly to any kind of changes in the supply chain, because you have those. You've already thought of it, right? You've already thought of it. But the cost up front of figuring all that out, I think, to your point, if you're doing it manually and someone has to decide that, is high, right? Because someone, either the in supply chain or engineering or manufacturing engineer has to decide, like, what are the alternate routes? What are the alternate components? What are them, and how many of them are there? You have to have that data kind of pre-thought out before you can put it into the system. Well, even if you had it all pre-thought out and you have to manually enter it, well, now it's like, oh my gosh, I got all the effort to design it in alternate ways, all the effort to then enter all of those different scenarios, right? It's just the compounding effect. And so as a result, what happens probably is people go, I'm just going to do, one, right? Which is one way to do this because we need to get it into the system and get it manufactured. I'm not going to mitigate the risk of a supply chain disruption right now because, like, does it happen often enough, or it's not the most critical thing, or we got to get it in there and ordered and made faster, right? So it sounds like some of what you're saying is a bit of like risk mitigation strategies, the ways you can do that. But if, I think you are alluding to, if like how we would help with that, of course, would be such a scenario where we make the part of taking from making it easier to engineer and helping leverage our integration and intelligence to turn it into those multiple bills, multiple routes, multiple vendors, allow you to build that scenario out much more quickly. And so the sort of cost benefit analysis, because you're saying, well, what used to take me, say, 8 hours to enter all of this data with all the alternates to kind of cover our rear ends just in case. What used to be two bigger hurdles, like, it's not really that big a hurdle now, right? We can do that pretty quickly, easily with this, with our systems, with our ERP. It provides that ability. Our integration and our design team can quickly develop those. We can get it into the system and built out right away. It makes the barrier for doing that a lot less because the work is a lot less. Did I understand that right?
That's right. I mean, I actually have a really concrete example of this that we actually did, because we do nesting integration too, right? We have nesting integration that we do a lot of times. And it's a good example, lends itself to that, is that like years ago, we used to make a lot of parts on laser, and they would be different finishes on stainless steel. So you have what they call like number 3 or number 2, or number 3 or number 4 finish. Hopefully I had that right. So number 3 finish is essentially a polish or a grain on the stainless steel on one side. It's number 4 finish is a polish of that same material on both sides. Okay. So just basically where the polish is, right? So if you're not seeing if you're not seeing the side with your visual eye, it doesn't need the polish, but it does. Then you can save some money on material, right? By not using number 3 over number 4. But when you're laser cutting, a lot of times, especially if the parts are small, the more small parts you have in a nest, the higher the yield of the nest is for cutting. So you're cutting on that. So one of the things that we did years ago that was really savvy was that we said, okay, anything under a certain size can be made out of either number 3 or number 4. But that was a game time decision based on every nest. Because if I had number 4 on the if it only, it would be specified. If it specified number 3, that it could be either. If it specified number 4, then it only can be number 4, right? Because it has to be polished on both sides. So you'd say all the parts that are specified number 3 have an alternate material available to them of number 4. If we're already cutting number 4, right? So you have the part of the thing, and then so you can make this kind of game time decision of like, I'm going to go ahead and fill the nest up with these parts that I need, which because it doesn't really matter if it's number 4 or number 3. It's going to cost a little bit more, but I'm going to take that extra cost to lower my lead time so I don't have the golden sprocket problem. And that's literally adjusting to a supply chain real time. It just had to be an internal supply chain that you had number 3 or number 4 on the laser at that moment. Right. Does that make sense?
Yeah. So same analogy, if it was not an internal supply chain, but an external supply chain. If I can't get this, for example, if I can't get this type of material to make, to your point, if 3 or 4, if I can't get this type of material, I can get this other one. Yes, it's a little more expensive, but I have options if I get that material. If I don't get that material, I can't do anything.
Right.
But you would have to be able to build out first of all, be able to build out all those alternates, build out all those, all of those scenarios so that you could be more resilient to supply chain. But if you're not tracking any of those things, or if you're not making those decisions, you're essentially doing it one-off, right? When you're presented with like, hey, you can't get your material and you have no alternates, and you have to figure out all that out on the fly, and how slow that can be.
And that's the thing is like, this is the world that we're going into. I think a lot of people don't realize with the world of AI, those types of intelligent decisions will be done in instants. Where it used to be had to go to a person who had to look at it and do an analysis and decide. Like literally we'll be able to decide that for us and say, you know what, this is basically the same as this. Go ahead and make that change. And like, so we're democratizing intelligence. Right. And so when you have a world with those types of things can be done almost instantaneously, like that all the equations change, and the way that you do things would be a little bit different. So you're like, well, I'm not gonna put this in anymore because it takes so much time to put in the alternates. But what happens when the alternates are being created with less time than it took to do the first one?
Right.
Then all the equations change.
Yeah, you're getting to what I was kind of thinking in my own head, which was like, if the barrier to entry, or the barrier to doing the work that you're kind of avoiding for good reasons, right? All good reasons, but if that barrier to that goes to nothing or near nothing, then you would just do it, right? You would automatically be done. So that intelligence would automatically figure that out, and you'd be able to do all of that without having to have a manual or process, or a person's look at that and make a decision. It just can be done automatically. And so then it makes things more resilient. Now, of course, we're mitigating the risk of those supply chain disruptions. And at the end of the day, there's still disruptions, right? There's still a change from the norm. So it's not going to, no matter what you do, it's not going to eliminate those disruptions. It will be a disruption, but the question is how big of disruption, right? Is it a little speed bump, or is it, a break in the road, right? Which one is it, right? That's the big difference.
Yeah. And it has to do with like, how resilient are you to that? And, and then how resilient are you to that disruption? And then even better, if you could be what they call anti-fragile,
right.
So the anti-fragile being really like, well, isn't that the same thing? And it's like, actually it's not. The anti-fragile means that when you have a bump, when you were like, well, first, resilient means when something goes wrong, how long does it take you to get back to your steady state? Anti-fragile is when you actually return to a better state. So you're like, actually, by doing this, I reacted. We found out that it's actually cheaper to go over here.
Right.
Because the disruption actually made the process better.
Yeah, that's a good point. That reminds me of a story you used to tell me. I feel like the longer you and I have been brothers, right, these stories keep coming back up. But there was this story you told me when you were working in manufacturing about standardizing on sheet metal, and that you kind of came to that accidentally. But with this intelligence and these kind of disruptions that can make you anti-fragile, it can actually lead to better results in the end.
It did. Yeah. I mean, we were standardizing on like 2 different sizes of material sheets. And what we realized was, and we did that because we knew that we could get that material, the supply chain was favorable for that material. But then we realized that we were cutting that material on lasers, and by standardizing on that material, even though the incremental cost of some of the parts went up, the actual cost went down because we were getting better yield on so like a series of what seemingly looked like a series of bad decisions led to an ideal result.
Right.
So bad decision in the micro, great decision on the macro.
Right.
When you combine everything together.
Yeah. It kind of reminds, that's why I brought it up, is like, cause it's in to lend itself to this thing where supply chain disruptions, if you're anti-fragile, right, you're resilient, you can get, but not just resilient, but you can actually get improvements. But again, it's only if you're ready for them, right? And your system is built to such a way that it is anti-fragile, and you can take advantage. To your point, like disruptions or changes, kind of like the market, right? When the market goes down or things get changed, there's money and benefit to be had there.
Mm-hmm.
But you got to be in a place to be able to do it, right? If you're not in that place to be able to take advantage of it, you won't be, right? You won't take advantage of it. It'll actually just where you'll get farther behind because your competitor or other people will be taking advantage of it while you're still struggling to kind of get back to baseline.
Mm-hmm. Exactly.
Well, Scott, it's been a good conversation. So some key takeaways I had, I learned something about, supply chains and not just supply chains and how complex they are and really how global they are and what can happen when supply chains happen. But we have supply chains. I think what I always thought about supply chains is like that they were global and that, we buy stuff from other places. I didn't really think about like supply chains can be internal, right? It can be just getting them from internal or even from a local source. It's still just that process of getting what you need, right? To manufacture what you need. So that was really valuable for me in terms of understanding supply chains and really how important they are. And also where they are disrupted, if you're anti-fragile, you'll be able to come back even stronger.
Absolutely.
So thanks for listening. This has been a good conversation, regardless of what happens in terms of the supply chain, whether that's through tariffs or through other disruptions. I think it's important that we can focus on what we can do, right, to make ourselves more anti-fragile. We can be more resilient, and so we're trying to help our customers think about those things, improve their processes, improve what they're doing every day, so that when things like this do happen, they can respond. So thanks guys for listening. Feel free to come to the website, cattalk.com. Read our blog, read about supply chains, read about nesting, any of those sorts of things. Subscribe to your podcast here on YouTube or Spotify or anywhere you get your podcast. Feel free to write in or make a comment. Other topics you'd like to hear about, me and Scott talk about that you think are relevant to manufacturing or integration. Anything else left to say, Scott, before we sort of close this topic on supply chains up?
No, I think that was great.
Okay, thanks everyone. We'll see you next time.